All right, this is verifying identities day one. And essentially what this is we're going to work with one side of an equation and we're going to attempt to get it to look like the other side, usually like the equals. So if you kind of look down here, we're going to attempt to make one of these sides look like the other one. And in order to do that, we have to use a lot of properties of trig. So we're going to recap all of our reciprocal identities, our quotient identities, and then I'm going to introduce you to something new called Pythagorean identities. So the reciprocal identities are just the flips. So knowing that the sine function, the trig function, is the same as 1 over cosecant of theta, and then vice versa. This one would be 1 over sine. So these guys are called reciprocal functions because you just flip them and they are each other. So cosine goes with secant, so this would be 1 over secant, and secant is then 1 over cosine. Sometimes it comes in handy to flip one trig function into another, so this is a tactic you can use. Tangent is 1 over cotangent, and cotangent is 1 over tan. Cotangent and tangent also have some properties called quotient identities. So tangent is also sine over cosine, which we know we've actually done that in a previous lesson. So then cotangent would be the flip of that, which would be cosine over sine. The Pythagorean identities, I'm not showing you here how they come to be or where they come from, more like something you're kind of going to drink the Kool-Aid on and just believe me that they work. But these are three different identities that are used. They kind of have their roots in the Pythagorean Pythagorean theorem. So like sine is the y value of a triangle, cosine is the x value. So this y squared plus an x squared would equal 1 squared. That's kind of where these are coming from. What you need to know about these Pythagorean identities is they can be rearranged. And what I mean by that is as we are doing proofs today, or as we're doing some verifying, we're going to come across some things in our proofs that have squares, but they won't exactly match what we have here. So I need you to know that each one of these three can be rearranged. So if I were to just look at this bottom one, if I moved this cotangent squared over here, like algebraically, I would have 1 equals cosecant squared minus cotangent squared. That is another version of this identity. So this is a version, this is a version. Another one could be, what if I moved the 1 over there? So cotangent squared could equal cosecant squared minus 1. So that's just three different ones. There are more than that. I'm going to show you how to use them when we find squareds in our verifying identities. We're just going to come up here and rearrange them to match what we have in the problem. And each of these can be rearranged to be a variety of other substitutable things. So here are some hints when working with verifying identities. Work with one side of the equation at a time. Start with the most complicated side. A common tactic is to change all the trig into sine and cosine. You really want to get down to, two trig functions. Whatever they are is fine. Sometimes it works best to go to sine and cosine, but if you can just get down to 2 trig functions, you are going to have a lot of success. Think about how many different pieces there are, how many different terms will you need to add. That could lead to common denominators. Look to factor or take out a common factor, kind of like 5x plus 5 could get us 5 and x plus 1. Only we won't be taking out numbers, we'll be taking out trig functions, but that idea that you could take something out. And the last one is super important. Always try something. Even dead paths and paths tell you something about the route that you took. Like that isn't, or that algebra didn't work, so let me come back and try something else. So just make sure you keep trying. First one, I've got sine equals cosine times tan. The more difficult side is this one. I got 2 trig functions. So in verifying, you're trying to make sure that this side does in fact equal sine. So cosine, I've got 3 trig functions, a cosine, a sine, and a tangent. So I'm going to try and get that down to 2. I can turn tangent into sine and cosine. So it's going to be cosine times, and then tangent is sine over cosine. And when you multiply fractions, you multiply straight across. No need for a common denominator. This will just be a 1 under there. And the cosines will cancel, 1 on the top, 1 on the bottom. So I have sine is equal to sine. So we just verified that what was on the right is indeed just a sine x. Same kind of concept. The more difficult side is the left. So I've got sine times, and then I've got cosine x and sine x. So kind of same idea. Anytime you were multiplying, they actually share the denominator. So these guys will cancel, and I have cosine equals cosine. So not too bad. That's kind of very simplistically how verifying goes. Of course, they're going to get more difficult than that, but you're just looking usually to substitute something and start canceling until you get down to where the two sides are equal to each other. So 1 plus tangent squared equals secant squared. This is an identity, just straight up the way that it is. We're going to prove the identity, so I'm going to go ahead and turn these into sines and cosines. So 1 plus, and this would be sine squared cosine squared equals, this would be 1 over cosine squared. In order to add two things together when one is a fraction, we have to have a common denominator. So the fastest way is to put the cosine squared underneath, and then you would also have to multiply by cosine squared on top. So on top I'd have cosine squared plus sine squared all over cosine squared. So the whole point to doing your common denominators is to mush those two fractions together into one. And then using our other Pythagorean identity, that sine squared plus cosine squared is a 1. That means that all of that is gone, and I've put a 1 in its place. So just some substitution in order to get it right to the end. So we substituted tangent for sine and cosine. We substituted secant for 1 over cosine. Did a little common denominator, multiplied by that, put our fractions together. This is an identity. Cosine squared plus sine squared is a 1. And now I've got the two sides being equal. A couple more here. First one, I've got a lot of different x's all over the place. Right now I've got 1, 2, 3 different sine functions and 1 cosine squared function. So kind of like the oddball out there, that cosine squared function doesn't quite belong since everything on the right-hand side is a sine. I have to get rid of that one somehow, like it doesn't quite fit. So this is what I'm trying to hone in on. I kind of want to get rid of that. So one way is I could take both of these terms right here, both have a sine in them, so I'm going to take that out. I'd be left with cosine squared minus 1. If I go up and look, cosine squared minus 1, that is the start of an identity. I have a cosine squared here, but the 1 is over there. So imagine algebraically if I moved the 1 over here, it would be minus, and then I would have to move the sine squared over there, and that would be negative theta. Sorry, theta. So if I could rearrange it to be cosine squared minus 1, that would actually equal negative sine squared. So this is going to come out. I'm just substituting what we just found. It would be negative sine squared. And then when I multiply these two together, I get, negative sine cubed x. Two more. Number 5. I have got 4 different trig functions. That's a lot. This is one of those cases where you want to get it down to 2. That's way too much stuff going on. So tangent is going to be sine over cosine times this sine function. Make sure you keep it up top or put a 1 underneath it so you remember. Then a cosine. You can put a 1 underneath that one. And then secant is 1 over cosine. So at least now everything is in 2 trig functions. When I multiply, remember you can just multiply straight across, so they can all share that denominator. So I have a sine squared over cosine plus a cosine. Now in order to add 2 fractions together, I would need common denominators. So I need to put a cosine down here to make them match. And then that means I need to put another cosine up here. So cosine x. So I've got sine squared x plus cosine squared x. That makes 2 of them, all over cosine x. And we just used this property in the last one, but cosine squared plus sine squared, that is one of our identities. So that's just a 1. I'm taking that out and putting a 1 in. And then on the other side, I also have 1 over cosine x. One more. It looks a lot like number 4. I do have only 2 trig functions, so that's as good as it can get. Switching these all into sines and cosines will introduce a lot of fractions. It's totally doable, but if you don't particularly like fractions, I wouldn't make them where they don't need to be. So I'm already down to 2 trig functions. Like I said, I can't do any better than that. So I'm going to look at this term and I'm going to look at this one. They both have a cotangent, so I'm going to take that out. I'm left with a cosecant squared minus 1. And then this is an identity. Squareds and ones should tip me off. So I'm going to come look for a cosecant squared minus 1. And just using this one, you could have said, okay, well, if I minus the 1 over here, so it is cosecant squared minus 1, then the cotangent would be left by itself. We also solved that earlier, and we are like, hey, if we did this, this is what it would be. So this cosine squared minus 1, oh, excuse me, becomes a cotangent squared. And then a cotangent times a cotangent squared is cotangent cubed. And that is kind of your first day trying, verifying identities. So stick with your steps, please. Try and get it down to 2 trig functions and watch all your normal algebra skills, common denominators, taking things out, and canceling.